Hey there everyone! Welcome to Math Tutor Hub where math finally makes sense. I am your math teacher for today. I am Sir Aaron Justin Beltran, but you can call me Sir AJ for short. Now we will tackle about proving theorems of a parallelogram and a rhombus. Now grab a notebook and let's learn together. A parallelogram is a quadrilateral where opposite sides are parallel. So here are the properties of a parallelogram. So first, opposite sides are equal. Second, opposite angles are equal. Third, the diagonals bisect each other. And fourth, consecutive angles are supplementary. So, and on the other hand, what is a rhombus? A rhombus is a special type of parallelogram where all four sides are equal. So here are the additional properties of a rhombus. All properties of a parallelogram apply. Diagonals intersect at right angles, and diagonals bisect opposite angles. So today, we're going to prove two important theorems. So theorem number 1, the diagonals of a parallelogram bisect each other. And theorem number 2, the diagonals of a rhombus are perpendicular bisectors of each other. So now, let's break each of these down. So, first, let's prove that in a parallelogram, the diagonals bisect each other. That is theorem number 1. Given a parallelogram A, B, C, and D, parallelogram A, B, C, and D, with diagonals AC and BD. Okay, intersecting at point E. Intersecting at point E. So now, to prove, AE is equal to CE and BD is equal to DE. Okay. Now, in a triangle, say we have here the triangle A, E, and B. So this is our triangle A, E, and B. Okay, triangle A, E, and B. And triangle C, E, and D. C, E, and D. Okay, now line AB. Line AB is parallel to line CD. Okay, very good. Now, line AD is parallel to line BC. Okay, by definition of a parallelogram. So now, angle AE and B, this is the angle AE and B, and angle CE and D are equal. So vertically, this is a opposite angles. These are the opposite angles. So angle AE and D, B is equal to angle CE and D. Okay. Now, the opposite sides of a parallelogram. These are the opposite side of a parallelogram. Side AB and side CD. This is the opposite side AB and side BC, CD, should say, is equal. So now, angle BAE, this is the angle BAE is equal to angle DCE. Okay, these two angles are equal. BAE is equal to angle DCE. Okay, now angle ABE on the other hand, angle ABE is equal to angle CDE. Okay, angle ABE is equal to angle CDE. So by ASA or angle side angle congruence, triangle AEB is congruent or equal to triangle CED. Okay. Now therefore AE is equal to CE and BE is equal to ED. Again, AE is equal to CE and BE is equal to DE. Now, the theorem number 1 is now proved. Now let's go to theorem number 2. Okay, theorem number 2. Now let's look at the rhombus. I will draw here a rhombus. Rhombus PQRS. PQR and S. With diagonals PR and QS. Diagonals PR and QS intersect at O. Okay, to prove diagonals are perpendicular, so angle POQ equals to 90 degrees. So POQ is equal to 90 degrees. Angle POQ prove all sides of rhombus are equal. Okay, so line PQ is equal to line QR, and line also it is equal to line RS and also line SP. So all sides are equal. All sides of rhombus are equal. So the diagonals of parallelogram and thus the rhombus bisect each other at O is the midpoint of both PR and QS. Now consider triangles POQ and triangle ROQ. Line PQ is equal to line RS given. So OQ is equal to OQ. That is the common sign. Okay, now PO is equal to OR. That is diagonal PR is bisected. Okay, PR bisected, PO and OR. Okay, so triangle POQ is equal to triangle ROQ by side congruence or SSS congruence. Therefore, angle POQ is equal to angle ROQ. Okay, since these are adjacent angles on a straight line forming diagonal PR and they are equal, they must each be 90 degrees. So each of these is 90 degrees. Okay, Hence, diagonals are perpendicular bisector of each other. Okay, so now let's look at a real example problem. Given rhombus ABCD, C and D with diagonals AC and diagonal BD intersecting at E. So if AC is equal to AZ is equal to 10 centimeter and BD is equal to 24 centimeter. Find the lengths of AE and EC, length of BE and ED. So now, since diagonals bisect each other, AE equals EC. AE is equal to CE and BE is equal to ED. So that AE is equal to CE is equal now to AC and BE is equal to ED is equal to BD. So if the diagonals bisect each other, since the diagonals bisect each other, AC, we can now divide it by 2 and BD divided by 2. So AC divided by 2 is equal to 10 divided by, the given AC is 10 centimeter, so 10 divided by 2, and BD is 24, so 24 divided by 2. Okay, now 10 divided by 2 is equal to 5 centimeter, and 24 divided by 2 is equal to 12 centimeter. Okay, now check if diagonals are perpendicular. Use the Pythagorean theorem in triangle AB and E. So we can now use the Pythagorean theorem. Check AB squared equals AE squared plus BE squared. Okay, so we will erase this. Check if AB squared is equal to AE squared plus BE squared. Okay, A squared is 5. 5 squared. AE is 5 because we divided by 2 the AC. Now AE is 5 and BE is 12. Is 12 squared. Okay, now 25. 5 squared is 25 plus 12 squared is 144 is equal now to 169. Okay, now AB squared. So what are we gonna do is we use the square root. We will square root 169 to become, what is the square root of 169? It is equal to 13 centimeter. Okay, now AB, side AB is 13 centimeter. So a rhombus is has equal sides. So side AB, since AB is a side of the rhombus and all sides are equal, we're good. Okay. And angle AEB is 90 degrees, so the diagonals intersect at a right angle. So let's have a quick recap. Diagonals of a parallelogram bisect each other. Diagonals of a rhombus bisect at right angles.
If you found this video helpful, don't forget to like, share, and subscribe.